Okay, so let's start. Every morning when we do when we start our class, we have to go through the land acknowledgement. We recognize we are hosting the lands in Mississauga of the Anishinaabe, the Haudenosaunee Confederacy, and the Wendat. We also recognize the enduring presence of all First Nations, Métis, and Inuit peoples. Okay, so now we go down to the announcement. Every single day, I post what we're going to be doing. So today is day one, right? Day one, July 2nd. This is what we're doing today. 9 o'clock. We're doing defining or this is what you'll be doing. I'm going to cover some of these through the lesson, but again, it's only an hour. So I'll be talking really quickly, but you may have to go in the content section where I'll show you where to find it and work on the lesson. And then you have a quiz, which is due 11:59 a.m. or p.m. tonight, okay? And you're given 2 attempts. Okay, so let's go up to, let me just move this. So that's just in my way. Okay, so under content, maybe I should just, no, I need that there. I'm gonna view it as a student. I gotta see what you guys can see. I wanna make sure you guys can see what is supposed to be seen. Okay, so content. Oh, okay, you don't even see unit 1. My bad. This is the reason why I have to double check that every time. I thought you guys can see unit 1. I guess not. Unit 1, you can see it now. You should be able to see it. Okay, so I'll just keep it like this for now. So we're gonna go through, let's start up over here. We're gonna define what's a function. We're gonna look at function notation, and we're gonna investigate what's domain and range, okay? Those are the foundational stuff you should know for functions. So under content, this is where I put everything. Also too, when the recordings are done, they go into here. So you're gonna see, for most of you guys, or some of you guys, I see there's 24 students online. Some of you guys didn't go through the orientation video. I know I'm going off topic a little bit, but I need some of you guys to go through the orientation video, and then when you're done, fill out this Google form. Okay. One of the things that we want to make sure you guys understand is that this course goes by quickly. To be successful in this course, right? I say all this stuff in the orientation, that's why you need to watch it. But the main thing is to be successful is to come online every single day and listen to the lesson and do the quizzes every single day. Okay. Do the lessons, go through the lessons, and go through the worksheets, which there's some worksheets here. Okay. Actually, no, I just give you guys the lessons. And then also too, I give you, turn this on, there's a video here, which I go through together with you guys. But you guys can't do that on your own. It's the best way to learn is to be in class as I go through the lesson, and then go through the lesson again on your own. Okay, if you go through the lesson on your own without having you may have some difficulty and you may not, and you'll be stuck and you may not know what to do. But if you hear the lesson when I'm presenting it, maybe it'll help you to when you go back to look it over again. Okay, so that's why it's important to come to class. Okay, 1 day is like 1 week. If you miss a day, it's like 1 week. Every day, wow, there's more people still in the waiting room. Let me get these people in. Okay, guys, for those who just came in, you really got to come at 9 because I let you guys in and I start going through the lessons. You miss stuff. Maybe you'll watch the video afterwards, but you don't want to be coming in late, please. Okay. So let's get started. We're going to start with functions, domains, and so.
Here's the first lesson.
Okay. Let me maximize the screen so we can see it better. Okay, function, domain, and range.
Lesson for the grade 11 functions course. In this lesson, what we're going to do is look at first the difference between a relation and a function. Next, we're going to learn how to use the vertical line test to determine if a relation is a function or not. And lastly, we're going to learn how to state the domain and range of a relation. So, start off with what's the difference between a relation and a function. So first things first, let's get the definition.
Okay, so let me go kind of, pause here. So a function back in the day is basically, okay. Okay, I got it. Thank you for being here. Okay. So I was just responding something in the chat. So a function is similar to a relation, okay? But a function is in terms of x, okay? So let us go through it again.
Definitions out of the way. A relation is most simply put a pattern between two variables. We can represent this pattern using ordered pairs, table of values, graph, and equation, and you would have seen relations described this way all throughout your math career. So next thing we're going to do is be able to determine whether a relation is a function or not. So what is a function? A function is a special type of relation in which each value of the independent variable, x, corresponds to exactly 1.
Okay, so that is key what he just said there. A function is the relationship between x and y. There's only one x for every y, okay? That is the key. Relationship could be two things paired together, but you can have maybe an x and you can have multiple y's, but in a function, you can only have one y for every x, okay? And you'll see that. We're going to see the graph and you'll see what we mean.
Value of the dependent variable, y. More simply put, for a relation, so if we look right here, for a relation to be a function, there must only be one y value that corresponds to a given x value. That's the most simply put definition there. For a relation to be a function, there must only be one y value that.
Okay, one y value for every x, okay? So here we'll show you is an example, right? So we're looking at y is equal to x squared. Y is equal to x squared. X squared, that's a parabola, right? So for every x, there's only one y value. There's no duplication. If x is -3, well, y is 9. More people are coming in late. When x is 0, y is 0. It doesn't duplicate, right? Now, if you were to look at it the other way around, this here is not a function because if x is a certain amount, y could be a couple of the same numbers. So watch, if x is 9, y could be -3. If x is 9, y could be +3. Okay, we look at that, right? If I plug in -3 for y here, -3 squared gives me 9. If I plug in 3 for y, 3 squared gives me 9 again. So I have two values for y for x, or two y values for x for the 1x. Therefore, it's not. It's a relationship, yes, but it's not a function. Okay.
Let's look at a couple different relations.
And now he's just going to say what I just said. So I'm going to fast forward a little bit. I'll play a little bit what he says, and we'll fast forward.
Ordered pairs. If we were to graph those ordered pairs, here's what the graph of y equals x squared looks like.
There you go. So you can see here with this graph, wherever I put a point, there's only one, for every x, there's only one y value. So this x here, x is 3, there's only one y value. Okay.
A parabola. This relation you may not be.
Now with this one here, we're gonna see the graph of this one. Okay. So if you see the graph of this one here, okay, fast forward a little bit, you'll see. Now that's the graph of this one here. Okay. X equal to y squared. You can see if I have x is 1, well, y could be 1 or it could be -1. Okay. If x is, I don't know, 9 over here, well, 9, if x is 9, that means y could be 3 or it could be -3. Okay. So this is not a function. It's a relationship, but it's not a function. They're gonna call, the next thing that's gonna happen is, in order to know, is this thing called vertical line test. If I put a vertical line all the way through this graph, if I have two values of y, therefore it's not a function. So that's another way to figure out.
I'm going to use what's called the vertical line test. Just to introduce you to the vertical line test, what we're going to do is draw vertical lines through x equals -2.
And that's what he's going to do. So I can fast forward that. He's going to draw a vertical line. If you draw a vertical line through here, you're going to see you're only going to get one x value and y value. Over here, you're going to have an x value but two y values. So let's fast forward. So there you go. See the vertical lines? You know which is a function, right? So fast forward, not a function. And the other one is a function. Okay. So let's fast forward. What are functions again? And what are, fast forward. Okay, he's just summarizing what we just saw. So I'll just play this out.
At this section here right now. That means each value of the independent variable corresponds to no more than one value of the dependent variable. So each x value has one y value, okay? So the relation y equals x squared is a function.
Okay.
The vertical lines.
Okay, so we get that. Vertical lines show if it only crosses one, gives you one value for y for every x, then you know it is a function. And we know that the independent variable is the y, sorry, is the x value. The dependent variable is the y, okay? So let's fast forward a little bit. Okay, so now we're looking at functions and seeing, we're going to determine if this is a function or not. Would you think this is a function if you look at this? This graph here was just a line, and it shows you right here, y is equal to -4x minus or plus 5. Is this a function? Or is it just a relation? Again, you can do the vertical line test. I want to see answers in the chat. I want to see if you guys are paying attention. Yeah, it is a function. Someone says yes, it's a function, right? If I were to use my mouse, move it like all the way down, I'm going to hit that line one spot. So it is a function, okay? And here's the equation of the line, right? And if we go back to grade 9, we know that -4 is the slope of that line, right? This is the line equation, so that's -4 is the slope of that line. And the +5 is the y-intercept. So it intercepts up there, and it goes down. My rise is going down 4, okay? But again, it's a function because my vertical line hits it in one spot.
Intersects the relation at only one point, then the relation is a function. If you draw a vertical line and it intersects the relation at more than one point, it is not a function. So let's use the vertical line test to classify each of the following relations as a function or not. So if I take a vertical line and I pass it through this relation, notice that it only ever touches the.
Okay, so you can see what he just did there. So you know it's a function. Now these ones here would, and this is at this point now, once you understand about the vertical line test, it becomes baby food, right? I'm going to pass this vertical line here. I hit 2 points on this graph, right? My x has 2 points for y. It has a y value up there and has a y value up here. Therefore, it's not a function. Over here with this graph, if I were to pass the vertical line through it, I'd only hit it at one spot. Okay? So it's not a function. Okay? It hits it twice there. This one's going to be a function.
As I pass it through the relation, it's never touching the relation in more than one spot. It passes the vertical line test. This one is a function.
Okay. Is this one a function? Anyone? Yeah, it's not a function, right? It's just, you see the circle, if I pass this line, it's going to hit it 2 spots. So it's not a function.
Lastly, we have a circle. A circle is a type of relation defined by the equation below. If I take my vertical line, pass it through this relation, notice.
There you go. So it's not a function.
Let's get the definitions out of the way. Basically, for any relation, the set of values of the independent variable, the set of values that x could be, is called the domain of the relation. The set of values that the dependent variable, so the y values, the set of corresponding values that y could be is the range.
So guys, I want you to just remember, maybe when you look at this graph, right? We say here, this is the x, this is the y. The x is always the independent variable, right? I'll put here IND. And the y is always the dependent variable, okay? You should know this because if you're in I don't know, chemistry class, biology class, or any science class, they always say the independent variable is always on the x-axis, okay? So the independent variable, right, is considered your x, and then we're saying here, if we're looking at what is domain and what is range, domain relates to the x values of the graph. Range is related to the y values of the graph. So if I have my graph like this, well, I'm looking at my domain. My domain is what is my x values. In this case, my domain can go forever, right? Because technically, I could go forever up this way or up this way and going along that way. I'm only looking at the x, right? So I'm going forever to probably to my right and then to my left. But for my range, I'm limited over here. I'm only going as low as this, and I'm going up forever, okay? So that's where you're looking at when you're looking at a graph. What's the domain and range? This is what you're looking at, okay? So let me just, and it's going to come up again. I just want to give you a brief introduction while we're going to watch this video again. Okay.
Of the relation. Note, for a function for each given element of the domain, there must be exactly one element in the range, meaning for each x value, there must only be one corresponding y value for the relation to be a function. And we've talked about that a lot already. More simply put, domain and range. Domain values.
Okay, so this is what I just said earlier. Domain, you're looking in the values of the x. For the graph, what are all the values of x, and then for the range, what are the values of the y? Okay, so let's look at this one here.
Little interactive activity here, just to maybe get you.
Okay, so now here's your graph. It looks kind of funky like this, and then you want to look at what's your domain and range. Well, this little exercise will let you know what the domain is. Right now, you're starting up there, you're going down to here, you're going up to there. Domain deals with the x, range deals with the y components, okay?
To be able to visualize domain and range. So I have a relation here, and for this relation, it only exists between 1 and 9. Most of the relations we look at are going to continue on forever, but for this one, it just exists between 1 and 4. So if we want to look at the domain and range, domain, we're looking at where does the function exist along the x-axis? Which x values could I?
Okay, so domain, we're looking at this one here. What are the values of the x-axis for this graph here? Well, if I look at the x-axis, just looking at x-axis, I'm going from this graph, looks like it starts at 1 and it goes to 9, right? So the domain of the graph is 1 to 9. That's what it looks like, 1 to 9. And the range of the graph, well, let's look at my lowest number is 3. My highest number is 7. So the range is from 3 to 7, okay? So he's going to say the same thing.
Plug into the equation for the relation, get a corresponding y value. So if I'm going to, so watch as this red dot traces along the relation. The part on the bottom here, this yellow dot, is going to trace along the x-axis as I trace along the function, and that's going to tell me what the domain of the relation is. So if I trace the red dot along, notice, look at the yellow along the x-axis. That's going to trace the domain of the relation. So as I move the red dot along, it's going to trace the domain of the relation along the x-axis in yellow. So notice the domain.
So there you go. It went from 1 to 9. The domain is between 1 and 9. And if you look at the range, which is in green over here, which is dealing on the y, it went from 3 to 7. So that's your range. Okay. Let us sort of fast forward. There you go. And this is considered bracket notation, right? So when you have the square brackets like this, when you write like this, it's telling you the range 1 to 9, and it means that the square means it equals to 1, and it also equals to 9. As you can see, it equals to 1 and it equals to 9. Okay. Same thing for the range. Okay.
So if we have a continuous function, we're going to write our notation like this. We're going to first say that x could be an element of real numbers. So a real number just means any type of number, rational or irrational number, includes integers, terminating decimals.
Okay, so this is always typical when you're writing the notation for domain and range, right? Usually you have, when you talk about domain, again, you talk about x. Okay, so you're looking at x could be any real number. Okay, that's what that means. And we're saying now if there is a limit, or sorry, it's a continuous line, then it could be between a range, or it could just be forever, which will just have any real number. Same thing for the y, okay?
Repeating decimals, non-terminating decimals. It's basically saying the function exists everywhere along the x-axis, except this is a given that sign. This means given that we're going to have to state some restrictions on the domain sometimes.
sometimes there are restrictions, right? And sometimes there isn't, right? So yeah, we'll come through examples for restrictions. Let us continue. Fast forward. Same thing with the range. It's the same way you write the domain. You write the same way in range. The only thing is you're writing it for the y component. Okay. Let's get to examples. Okay, so here are example to go through. Here are basically ordered pairs, coordinates, right? And basically you're looking at seeing what is the domain of this ordered pair. And the domain will just be looking at where does these group of numbers exist on the x-axis? Well, it exists from, and you can write the numbers in order, but it exists at -3, 5, -2, 5, and 6. Okay, so now watch how it's written.
Of the relation. So I'm going to look at only the x values. And typically you're going to want to write these in order. So a little curvy bracket. The domain x could be equal to, and we'll put them in order from least to greatest. It could be -3, -2, it could be 5, and it could be 6. If an x value is repeated, you don't have to write it twice. Close it with your curvy bracket. Range.
Okay, so that's your domain for these group of points. Now your range would be the same thing. You would have r dot dot and squirrely bracket. Y is equal to, start from the lowest to the highest. So you have -6, then, or sorry, -8, then -6, and then such and such 3, 4, and 7. Okay. There you go. So that's your range for this, okay?
Domain and the range of that relation. Part B, you'll do it a similar way. I'm not going to.
Yeah, part B is the same thing. The way you would write out what's the range, what is the domain range. Looking at this, your range. First of all, you have to determine what is the x, which is y. Okay, age and the number. Okay. In this case here, age is the independent, and if independent, that means it's x. Number means, I guess, number of students who are that old. Okay, so number of students that old and age. Okay, so let's fast forward. Domain is the age here, so you got 4 to 10, and your range is what's your lowest number, and then plot it to your highest number, okay?
Is a function because for each element in the domain, there's exactly one corresponding.
Okay, so the question here is, for the questions that we saw above there, right? So is this one a function? Is this a function? The question is the function? And the answer is no, it's not a function. The reason why it said no, it's not a function is because you have duplicates for your y values for 1x. For example, here is my x. I have 5 is my x, and then I have a -6. But then over here I have 5 as an x, and then I have 3. So this is not a function. Okay, there's duplicates there's duplicate y values for 1x. For b, it is a function, I believe. Let's see. I believe it is a function because there's no repeating. Okay.
At x equals 5 has two different corresponding y values, so it's not a function. But if we look at part B, there are no x values that are repeated. This one is a function. Part B is a function because for each element in the domain, there's exactly one corresponding value in the range. So for each x value, there's only one corresponding y value. Let's go ahead and now practice a couple. I'm going to give you the equation of the relation. We should be able to graph these just based on your knowledge from grade 9 and 10 math. If you're going to graph a linear relation, y equals 2x minus 5.
Okay, so graphing this is not it's not a hard thing. You guys should know this from grade 9, so I'm just gonna fast forward that. And then it says determine the range, right? So once you graph it, let's fast forward. That shouldn't be an issue. If first of all you're graphing that, you know it's a function, but it's a line equation, right? So you don't really need to do the vertical line test. You already know it's a function. And then the domain of it, if you look at it, right? Is there any limit of this graph? You look at it for the x value, is there any limit for x? This line goes forever, right? So if it goes forever, I can go forever this way. And let me do an annotation so you can see. I can go forever this way, and I can go forever this way. So there's no limit for my domain, which is, sorry, my x, therefore there's no limit on my domain. Okay. And same thing with my y. There's no limit on my y. I can go up forever, I can go down forever. There's no limit. Okay. So how do you write that when it's like that? Let's look at. Okay.
Ever to the left and right. I could plug in.
So he's gonna say that, and that's how you write it. There's no restrictions. So my domain is x can be any real number, and for my range, y could be any real number.
That basically means y could be anything. Let's do another relation. So we have a quadratic relation here.
Okay, so you know this is a quadratic, right? From grade 10, you plot this, right? And when you plot it, it looks like that. Okay. Fast forward, looks like that. So your domain, again, it looks like this could be any real. I can go this way forever, and I can go this way forever, right? It'll just keep growing and expanding, right? So my domain is going to be x is every x could be any real number, no restrictions for my x. But my y, there is a restriction. It stops right here. I go down, but I stop right here, right? I have a valley, and I come back up. So my y is restricted. I can't go past that value right there, which is 1, 2, 3, right? I cannot go lower than 3 on this graph. Okay.
There are no restrictions on x. X could be any real number. If I was going to continue this function forever, it would continue off infinitely to the left and to the right.
Okay, so we know that. So we fast forward that. And I said there's a restriction on the y.
Be always greater than or equal to 3. So what this means, y could be anything given that y is greater than or equal to 3. Our next one, y.
Okay, so when you graph this, it looks like this. Okay, it looks like that, and there is a restriction. When you graph it, you cannot go less than x has to be greater than or equal to 1. It can't be less because it stops there. Okay, and if you look at it, why does that be? Why is that? Because inside here, okay, it's back up so you can actually look at the equation. Here, x cannot be less than 1. If x is 1, this is 0. Square root of 0 is fine. But if my x is less than 0, say it is, or less than 1, that means you'll have a negative inside here. You can't square root a negative, right? It's an error. Therefore, that's why x cannot be less than 1. Okay. And as a result, because if I'm saying my x is 1, that's going to be 0. And then my y is going to be 3. So that means my y is going to be 3, and it could go up, because if x is another higher value than 1, then it's going to be higher than 3. So I can't be no less than 3 for my y, okay? And I cannot be less than 1 for my x, okay? I think he'll let me just let him play it for you so you can hear it.
And then I'll explain why I have these answers for the domain and the range. So here's what the relation looks like. So right now you would probably have to graph this by making a table of values. And if we do that, we would get the relation that's in green here. And notice for this relation, I should draw my little arrow here. So this relation.
Okay, I'm going to fast forward because we just went through. I thought he would have a shorter explanation, but basically, you can see there, you can't have a negative. You can't square root a negative, so it won't work. Okay. This one here, well, with this graph, you graph this, you know it's going to be a circle, right? That's the equation of a circle from grade 10, right? So it's going to look like that. The domain, let's see what it says.
1, 2, 3, 4, 5, and a bit more. Not that far. And I don't know if it's going to let me do it. It's lagging too much. I hope it doesn't crash on me here. I think it's about to. Okay, let's go to the other one where I have it drawn already, because I think it's about to. Okay, there we go. Okay, now it's moving. Yep, it crashed. Okay, let's go to the one I have done. Okay, if we look at this one, I drew a circle, radius of 600 at the origin. Notice this circle, this relation, doesn't.
Okay, so you can see here is your circle, and if you're going to look at your x, you're looking at your domain. It's all in between this point here, which is 1, 2, 3, 4, 5, 6. It's -6 and +6. So my domain is between -6 and +6. And my range, since it's a circle, it's going to be the same over here, -6 to +6. Okay, my y value could only be in between this area. My x value could only be in between this area here. Okay. Okay. Here is another function where you have an asymptote. Okay. This asymptote shows you the value of. First of all, it's an asymptote because you cannot have. You can never get to 0 with this, right? If x is, your y can never get to 0, right? That's what that is. It'll never hit the 0 line. So if I put x is equal to, I don't know, even if I put x is equal to infinity, 1 divided by a number, you'll still get a number that's really, really small, but you'll never, ever, y will never, ever equal to 0, okay? And similarly, if you're looking at for x, you can never get to -3, right? You'll never get to -3, right? So that's why you have an asymptote at -3, and you have a asymptote is a vertical asymptote at -3, and a horizontal asymptote at 0. Okay.
Asymptotes. I'll just really quickly explain what an asymptote is and why they exist for this relation. But we'll talk more about asymptotes later as we start graphing different rational functions, and you'll spend a lot of time with asymptotes when you take advanced functions next year. But basically, there is what's called a vertical asymptote, so an invisible line that our relation cannot touch. It can approach and get very, very close, but it will not touch. There's a vertical asymptote at x equals -3. Why -3? Well, if we look at our relation, if x was -3, if I plugged in a -3 for this x, I would have -3 plus 3 in the denominator. -3 plus 3 is equal to 0, so I would have 1 over 0. And you know that dividing by 0 is undefined. You can't do it.
Okay, that is the reason why you have a negative 3 as a vertical asymptote. You can never divide it by 0. If you punch it in your calculator, 1 divided by 0 gives you an error. So it'll get close to 3, to -3, but you'll never touch it, right? And so that's the answer, or that's the reasoning for why you have an asymptote at -3.
So there will always be a vertical asymptote at any x value that makes your function undefined. Okay, that makes the denominator 0. So there's a restriction for our domain. This relation exists everywhere along the x-axis except at -3. X cannot be -3. That's why I've defined the range as being x can be any real number, but it cannot be -3. There's an asymptote at -3 because if x was -3, it would make the denominator 0, and we can't have that. We can't have the denominator being 0. There is a vertical asymptote at y equals 0. So y equals.
Okay, so again, now we're doing the asymptote at y is equal to 0 because you can never ever get to 0. Let him explain it, and I said it, but let him explain it again.
0 is actually the x-axis line. There's a vertical asymptote there. Notice this relation, if we start at -1, it's going off towards positive infinity. But as we move to the right, it gets smaller and smaller and smaller and gets closer and closer and closer to 0, but never touches it. If we look at on the other side of the asymptote, if we start at this value here, notice it's going off to negative infinity as it gets really close to -1 along the x-axis. And as we go to the left, it gets closer and closer and closer to 0, but never quite gets there. So there's a horizontal asymptote at y equals 0. And there will always be a horizontal asymptote at y equals 0 if the denominator of a function is a higher degree than the numerator. The numerator in this case is degree 0, the denominator is degree 1, the variable has an exponent of 1. Therefore, there's going to be a horizontal asymptote at y equals 0. There is no x value you could plug in that would make y equal 0. You can get really close. You put in a really, 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 really big x value.
Okay, so that was it right there. There's no x value that'll make y equal to 0. Okay, there's no x value. You can put infinity. It will never, 1 divided by such a large number will get you a small y value, but it will never, ever, ever get to 0. That's why there's a horizontal asymptote at y is equal to 0.
Value, you will get 1 divided by a huge number, which will be very close to 0, be 0.000000 something, but it won't actually equal 0. It'll just get very close to 0. So my range, y could be any number. It's an element of real numbers, given that y is not 0.
Okay, so now here is the explanation of asymptotes, which we kind of just did. Okay, let's see here. I'll play it out so you guys can hear it. I think you need to hear it.
Not be 0. So x cannot be -3, because if x was -3, the denominator would be 0. So we have to draw a vertical line at x equals -3 and call this an asymptote. The curve will get very close to it, but it will not be able to touch it. A horizontal asymptote, the line y equals 0 is a horizontal asymptote because for all functions where the denominator is a higher degree than the numerator, there will be a horizontal asymptote at y equals 0. I mean, it could be shifted up and down depending on what transformations are being applied, but for now it's always going to be at y equals 0. And I think that's it. If you want, you can pause the video here, read through these key concepts.
Okay, so let me stop the video here. So now you if we go back to I'll go back to the home page. Okay, so we talked about defining a function. We talked about function notation, investigating range, domain and range. That was in that video. But let's go back. And you can see there is a quiz due today. Okay, we saw that. Function notation. That's a little bit of it here. Let's see here. I'll turn this one on. He talks about a little bit, we already talked about it, but I'll play this one because we still got some time, so I'm going to play some of this one.
Here's lesson 1.2 for the grade 11 functions course. This lesson is called Functions and Function Notation. So now that you know what a function is, from last lesson we looked at different relations and determined how to classify those relations as functions or not functions. Now we're going to look at how to properly write functions using function notation. So function notation is going to look very similar to equations you've used in the past, with one key difference.
Okay, so when you look at function notation, let me just, this is in the way here. What it means is, instead of in the past, we would always say y is equal to, I read on the screen here. I'll do a line equation. Y, oops, my bad. Okay, y is equal to, I don't know, 3x plus 4. Instead of writing like that, we write function notation, we replace the y, and we'll say f of x is equal to 3x, sorry for the bad handwriting, 3x plus 4. You replace, like it says there, you replace the y with f of x. And the way you say it, you can read it out, you can say f at x or f of x, but basically you're replacing the y and we're putting f at x or f of x. That's how you read it, okay? So that's the way to write it in function notation. It looks like that. So all your your line equations that you wrote like this, now you write it with f of x. All your quadratic equations that you had with y is equal to, replace that with f of x, okay? That's kind of the main thing.
Instead of having y equals something, you are going to have this, f at x, or f of x, it's sometimes called.
So let's fast forward. He's just saying what I just said. So let's see if we fast forward. And the reason why, the reason why you do that, because we're saying your equation is a function of their x, right? So here's your equation. It's a function of the x. Whatever x is, it will influence the value of your y, okay? So that's what that means, right? Takes an input of x, performs the operation on it, and then gives you an output of y, okay? I'll play it out and see, and so you can hear how he describes it, but it's the same thing what I'm saying.
That means the value of the function at a given x value, and that's going to replace y. So function notation, this is what it looks like. Like I said before, this f with the x in it with the x in brackets beside it means f at x. We can take any value of x we want, plug it in, and then our equation will tell us the value of the function at x. That's why we write it like this, f at x equals, and this f at x replaces y. So if you want, think of it just as like y equals. So let's practice using this notation. So the question says, for each of the following functions, determine f at 2, f at -5, and f at a half.
Okay, so what you're doing here is, so what is the value of the function, right? So basically the value function, what's the y value, right? At these values. So when it's written like this, it's saying here, f of 2, f of -5, f at a half. Well, it's saying here that my x is the value of 2. What is my value of y? So if I plug in here value of 2 for x, then I would get a value for y. Okay, so let's go through the first example.
What does that mean, f at 2? That means, what is the value of the function, what is the y value when x is 2? That's what that means. So let's go ahead and calculate. Let's do it for f at 2 first. Let's find the value of the function when x is 2. That's what this means. F, I'll do it in red so that we can keep the symmetry here. F at 2, that means what is the value of the function when x is 2? F at 2 is equal to 2.
Well, what is the value? Anyone know? You guys have been listening to me talk. What's the value of this f of 2? What's the value? I mean, let's see. Who knows? 0? Yeah, it's 0. You plug in, if my x is 2, 2 times 2 is 4, and minus 4, yeah, 0. Thank you, Anthony. Okay. So we can fast forward. We know f of 2 equals to 4. I mean, equals to 0. That means my y value, when I plug in x is equal to 2, my y value is equal to 0. Okay.
F at 2 is equal to 2 times 2 is 4, minus 4 is 0. So that means the value of the function when x is 2 is 0. So that means when x is 2, y is 0. So this corresponds to the point 2, comma, 0.
Okay. So this is my point now, right? This is the dot on my graph, right? So when when x is equal to 2, my y is equal to 0. Okay. Now let's do the next one. Minus 5. You plug it in there, right? So minus 5 times 2 is -10. -10 minus 4 is 14, -14. So if my x is -5, my y should be -14.
When x is -5, y is -14. When x is -5, the value of the function is.
Okay, so we know that. So now let's do the next one. It's the same kind of thing. What's my x is a half? What's my y? Fast forward that.
One minus 4 is -3. That corresponds to the point a half, -3. Because when x is a half, the value of the function is -3. When x is a half, y is -3. Notice I keep interchanging value of function and y value.
Okay, so that answers that. So let's go to the next one. This is more examples. Okay. This one here, if my x is 2, what is my y value? I got to plug it in there, right? So I plug it in there. Let's see if anyone can do this in their head. I plug in x equal to 2, what's my answer? Let's see if anyone has a calculator paying attention. 17. Okay, anyone else? That's one answer, 17. Can someone confirm that? Okay, there's two 17s. Okay, so that could be the answer, 17. Let's just fast forward it. It looks like someone said 17. Interesting. Yep, it's 17. Okay, so when x is 2, y is 17. Okay. And I know it's going to do for -5 and -0.5. We can skip all that. Sort of the same process. So I'll skip that. The only thing is you may have questions with the half, right? So you got to be able to learn how to use your fractions. Okay. That was what you would have to worry about over there. And here's another one. Here's another one. Let's see who can do this one. What would be if x is 2? Oops. Back up a little bit. If x is 2, what's my y?
A half, and we could do the same. Then it's just basic arithmetic from there.
Okay. Yeah, actually, we didn't go through the answer, but you can play with that on your own. Okay, so here's application. Okay, so you're gonna graph it. So you have a question like this, right? Where you graph it and then you figure out what is the domain and what is the range. Well, if you're looking at this, what kind of graph would this look like? Based on grade 10, what does this look like? This equation, what is it? What kind of graph would it look like? Give me a name of this type of graph. Anyone? Starts with a P. Let's see. Yeah, parabola, right? Remember, this is like the transformation, right? So my vertex is at -1 and 5. And is this going to open up or down? Yeah, because you have a negative there, right? The negative tells you it's going to open up, and it's going to be a stretch of 3. Okay? So you're going to graph it.
Recognize this is a quadratic function. So to graph it, I'd first
Quadratic, parabola, same thing, okay?
start by plotting my vertex at -1, 5. Notice A is negative, it's going to open down. Let's graph it a bit more accurate than that, though. Let's find a couple values to the left and right. So to the left, well, I'll do to the right. So to the right of -1 is 0. So if t is 0, so in this case, t is in place of x, and our y value is represented by the height of the function. If x was 0, or in this case if t was 0, 0 plus 1 is 1, 1 squared is 1, times -3 is -3, plus 5 is 2. So the height when time is 2, or the height when time is 0 would be 2. If I was to plug in, should I write this out? I'll do it very quickly. So what I did, I figured out the height when time was 0, and figured out -3 times 0 plus 1 squared plus 5. I figured out the height when time was 0 was 2. So that corresponds to the point.
Okay, so basically you plot it out, right? Which is what he's doing. Once you plot it out, let me fast forward a little bit. You plot it out, so it looks like your parabola. Okay, now once you plot it out, again, it can go down forever. What's your domain, right? And then what's your range? And so the first thing is the domain. There's no restrictions going on your x-axis. Okay, so your domain is I guess x is actually t here in this case. X is t. There's no restrictions on your x-axis. Okay, but there is restriction on your y. So you have a restriction on the range.
I guess in this case I should say t would be any real number because we're not using x, we're using t, but that's fine. X could be any real number. It continues forever left and right. I can plug in any number I want for the independent variable and get a corresponding value.
Okay, so you can get any number for t. Okay, now for your range, that's what he's going to talk about now.
Of the function. However, the range, remember we're looking at where does the function exist along the y-axis. This is the highest along the y-axis it ever gets, right there at 5. It never goes higher than that, but it exists everywhere below that. It continues off.
Okay, so it's going to be any real number. We should put h, but we're not going to put h. We're going to put y. So y is any real number. Technically, it should be h. Okay, and your y is less than and equal to 5. Okay.
Off down to negative infinity. So y could be any real number, given that y is less than or equal to 5. It's always at 5 or below.
Okay, so that's what we just said there. It can be less than or equal to 5.
The next part of this question asks us to evaluate the height when time is -7.
Okay, so when you have a question like that, all you're gonna do is plug in the value of your the time is gonna be t is equal to -7, and plug it in there and figure out what is your h. Okay, and I believe he plugs it in there, and then you get your value for h when your t is -7.
-7.
Okay, so fast forward, and then your answer is going to be,
Gives me -103.
okay, so that's your answer. So looks like we covered both of the lessons. Okay, let me see if you guys can access the quiz now, because the quiz is the next thing you guys got to do. To make sure you, so let me go into the quiz. Give me a second. Am I a student? Let me see if I can view as a student first. Just want to make sure you guys can see the quiz. There's your quiz. Okay, it's due 11:59. You have 2 attempts at it, like I said, and that is your assignment for today. Okay, so go through those lessons and then go through the quiz. I'm going to stop recording, stop sharing my screen now, and I'm going to stop recording now.